Hi friends, welcome to this class. So in last class we discussed about the CLF3 geometry, shape and hybridization. In this class let us discuss about BrF5. Before going further, let us see the structure of that CLF3 which we discussed in last class, right? So CLF3, I have this model. Let us see with that. So I told, so its hybridization was sp3d, and I told geometry will be always trigonal bipyramidal, TBP. So this is the trigonal bipyramidal, right? I hope it is clearly visible to you. So 1 2 3, one is above, one is below. See, one is above, one is below, and these three, 1 2 and 3, all are in same plane. See, if I take a plane, if I cut it like this, see, all these are in same plane. What all the 1 2 and 3 bonds, these 3 bonds, 1 2 3, if I take a plane and if I cut, all are in same plane. One bond is above, one bond is below, right? So chlorine was at center, this bond and this bond and this bond, all are in same plane. So it is forms a trigonal planar, and one is above, one is below, like this. So this is the structure of TBP, and I told fluorine, they will occupy these axial positions, because if you see, lone pairs will occupy these equatorial positions, because these lone pairs will be there, right? So electron density is more, and bond angle is 120 degree, so repulsion will be less. If lone pairs were here and here, the bond angle between lone pairs and fluorine was 90 degree, so repulsion will be more. So the structure will be like this. So if I want to show the structure like this, so this is the structure, right? One fluorine is above, one more fluorine is below, and this fluorine is here, right? So these white bonds indicate fluorine, and this blue point indicates this is chlorine, right? And lone pairs, you may ask, so one lone pair is here. I hope it is visible to you. One lone pair and other lone pair is here, right? So lone pairs I haven't attached. If I would have attached, let me see, I may get whether I have the box here. I have kept it inside only, I think. Yeah, lone pairs are here. Yeah, let me show it with these lone pairs. Yeah, it's good. Sorry for this waste of time. Just have some patience, so that you will learn clearly about the shape, size and everything, right? So see, these are the lone pairs. I can show it here. One lone pair, two lone pair, right? So these are two lone pairs, right? So one lone pair is this way, and one fluorine. All these two lone pairs and fluorine are in one plane. One fluorine is above and the other fluorine is below, right? So this is the structure, right? So I told, while counting hybridization, you should count lone pairs and sigma bond. So if you count lone pairs, 1 2, sigma bonds 3 4 5, total it is 5. So 5 means sp3d. So hybridization is sp3. But to tell shape, we should not see this lone pairs. If you remove this lone pairs, just I will remove one lone pair and two lone pair. Now you see, it looks like T shape, right? If I turn it like this, it is T shape, right? So we call the shape of this CLF3 is T shaped, because it looks like T only, right? So this is the thing which I wanted to explain with this, right? Now let us see the structure, everything of BrF5. So what is this BrF5? So bromine, we know that helium, neon, argon, krypton and xenon, and here fluorine is there, chlorine is there, bromine. So first period, second period, third period, fourth period. Bromine is fourth period, and this all we have seen in first class only, first video. There I told the bromine, its electronic configuration will be argon, right? And it will be fourth period, right? 1 2 3 4, yes, fourth period. So it will be 4s2, 4p5 and 4d0. So this is the electronic configuration which we have seen in first class only, right? So let me write it nicely here. Electronic configuration was argon 4s2, 4p5 4d0. So I will clearly write it like this. So it is P and this is D. 1, 2, 3, 4, 5. Right, D. So 4s2, 2 electrons, and 4p, 5 electrons. 1, 2, 3, 4, 5. And D0, no electrons. So this is the ground state electronic configuration of bromine. Right. So this is electronic configuration of bromine. Always we write the electronic configuration of central atom, which is bromine here. In ClF3, chlorine was the central atom. Right. So bromine. So this is the electronic configuration. Further, when this 5 fluorine comes here, it will get excited. I can show it by E star also. Excitation. So since 5 fluorine are coming, so it should make 5 bonds, right? So but it can only have only one bond it can form if it because it has got only one electron. Since 5 fluorine are attached coming, so these paired electrons are there, they will jump to this like this. One will jump here and from this one will jump here. So excited electronic configuration, you will see that this lone pair is there as it is. Here 1, 2, 3 and it is d orbital. And as soon as one jumps here, it will get 1. This one jumps here, it will get 1. Right. So now 5 fluorine can come and 5 bonds it can form. 1 bond, 2 bond, 3 bond, 4 bond, 5 bond. Because fluorine will come like this, right? But before coming that, they will, since they are having different energy, they will combine to give a equivalent energy. That combination is nothing but hybridization. How it will hybridize? 1s is there, 3p is there, and 2d is there. So it will form sp3d2. Above you should write sp3d2. Right. So how it will form? sp3d2, and this will be the sp3d2. Yes, 3p and 2d. Total it is 6. Yes, it will be having lone pair. P means 3 unpaired, 1, 2, 3 and 2d. Here also unpaired like this. Now fluorine will come. So fluorine means they will come with reverse spin, so that they can combine and they will form 1, 2, 3, 4, 5. 5 bonds they will form. Right. So hybridization is sp3. And I told if hybridization is sp3, geometry will be octahedral. Right. Octahedral means C. So this is my central atom, that is here in this case bromine, right? And here this is octahedral shape. This is we call octahedral, right? All are in single plane, 4 bonds, 1 bond, 2 bond, 3 bond, 4 bond. All are in single plane like this, 4 bonds, 1 bond, 2 bond, 3 bond and 4 bond. One bond will be above and other bond will be below like this. Sometimes they will show this hybridization like this also, or sometimes they will show like this circle in which center will be that bromine hybridized atom, and these things will remain in same plane. One will be above and other will be below like this. So with square also you can see, or with circle. But I think with circle I can represent 3 dimension very nicely compared to square, right? So if so, you please comment on the this comment box, right? So this is the thing, right? So if you want to see the structure, I will show, right? So this is C. This is the structure of octahedral, right? So this is the geometry of octahedral. So what is this octahedral? See, 4 atoms. I will hold this. See, 4 atoms. 1 atom, 2 atom, 3 atom and 4 atom. All these 4 atoms are single plane. If I take a plane like this, if I cut it, it will cut into all these 4, and the central atom also it will cut, right? So all 4 atoms are in single plane. One is above, one is below. So one is above, one is below, and all 4 atoms are in same plane, which I am showing here. If you see bond angle from above and to this, so here it is up, and to this plane the bond angle is 90 here, right? This is the plane and this is atom. Here bond angle is 90, here also 90. What about these things, all which are in the same plane? The bond angle is again 90 here, because see, 360 you can do. How many atoms we have? 4. 1, 2, 3, 4. Within that, divided by 4. 90 degree. So all these atoms are placed within the same place by 90 degree. So here also within these atoms which are in plane, if you see, it is again 90 degree, right? So bond angles will be 90 degree, right? So geometry is what? Octahedral, which I have written. But here, because of this lone pair, there will be disruption, right? So center, what I have? Center I have bromine. So octahedral geometry means 1, 2, 3, 4. All should be in single plane. One should be above and one should be below, right? So 5 fluorines are there. I will place like this: 1 fluorine, 2 fluorine, 3 fluorine, 4 fluorine, and 5 fluorine. And one lone pair I will place here below, right? Below I will place lone pair, right? So what is the geometry? Geometry is nothing but octahedral, and hybridization is sp3d2. But shape, I told, while telling shape, you should not see this lone pair. If you remove this lone pair, so here see 4 fluorine, so 1 fluorine, 2 fluorine, 3 fluorine, 4 fluorine, and 1 fluorine above. Yes, this is the fluorine which is above, and here I have lone pair, so I will remove that lone pair, right? So if I remove that lone pair, here lone pair is there. While telling shape, I told don't see the lone pairs down. If we don't see the lone pair, how it will looks? So square and one line, if I join it like this, 1 plane, 2 plane, 3 plane, 4 plane, so it will be like, see, 4 are there like this, and 1 fluorine is here. So if I join all those things like this, it will look like square pyramidal, right? Because all 4 fluorine are in one plane, one is above. If I just join like them with this, so it looks like square pyramidal, right? So geometry is octahedral, but shape is square, because 4 are in same plane, and its shape, if you see like this, 1, 2, 3, 4, its shape is exactly square, right? So this is square, so square, and 1 is above. If I join like this, it looks like pyramidal, square pyramidal. I told, while telling shape, we should ignore this lone pair, right? So if I want to show these as lone pairs, I can fix them here, right? And if I want to tell the hybridization or geometry, I told we should count the sigma bonds and also lone pair. So I should count the lone pair and sigma bond. So 1, 2, 3, 4, 5 and 6. So it is 6 means 1s, 3p, it is 4, d2, 6, 2, 3, 5 and 6, sp3, d2. So geometry and shape, and this is the thing. So this is how it looks, right? If you want to tell the shape, you just ignore this lone pair. So if I ignore this lone pair, it looks square and pyramidal. See, this is exactly square and one bond is above. If I touch all those things, it looks square pyramidal structure. So this is about BrF5. In this class, let us see the same geometry hybridization of IF7. Till then, take care and have a great day.